cumin. Okay, right. Fourth preparation. Yeah, Riddle craft calculation. Yes. Next, continue. Fourth preparation method. Fourth preparation method of phenol. Okay, right. From any soil. Preparation of phenol from any soil. Okay, see. Anisole or methoxybenzene. Anisole or methoxybenzene. Anisole, methoxybenzene, both are same. Methoxybenzene. Right. When anisole is treated with HBr or HI, hydrogen iodide, phenol formation takes place. Phenol is formed. OH, and byproduct is CH3Br. CH3Br. See the mechanism. Very easy. HBr dissociates into H plus and Br negative. Right. Oxygen is having a more electronegativity nature, so oxygen gets a negative charge. So imagine partial negative on the oxygen and imagine partial positive charge on the carbon atom. In HBr, which is having a positive charge, hydrogen. So hydrogen adds to oxygen and Br adds to carbon and break this bond. During addition, we break the bonds, right? Break this over. So phenol and methyl bromide is formed. Clear? From anisole. Got it, all of you? Right. Shall we go to next preparation method? Preparation number 5. From salicylic acid. Next preparation method from salicylic acid. Preparation of phenol from salicylic acid. Can you say, anybody, what is salicylic acid structure? Sorry? Benzene ring with the COOH and OH group. See, all of you, if benzene is having COOH, that is called benzoic acid. Benzene with COOH is benzoic acid. If benzoic acid contains OH group, that is called as salicylic acid. Parent compound is acid here, okay, not phenol. Okay, actually this is carboxylic acid with one substituent. Okay, you have to consider like that. Parent compound is benzoic acid. Orthohydroxybenzoic acid is the IUPAC name. It is commonly called as salicylic acid. Ortho position OH group is there. So orthohydroxybenzoic acid, it is also called as salicylic acid. Fifth preparation method, right? When salicylic acid or orthohydroxybenzoic acid is treated with soda lime, NaOH plus CaO, NaOH plus CaO, CO2 will be eliminated. Carbon dioxide. What is the role of soda lime? See, this combination is called as soda lime. What is its role? It removes carbon dioxide. Decarboxylation. See, all of you, CO2 will be eliminated. Minus CO2. CO2 will be eliminated. So what is remaining there? H is remaining there. and OH. OH. You no need to write H. Okay. If you write H here, or if you do not write H, nothing will happen. Still H is present there only. Clear? Right. Phenol is produced or not from salicylic acid. Decarboxylation, carbon dioxide will be eliminated. Got it, all of you? Is this preparation method okay? Any doubt in this? Right. Take screenshot and write later. Okay, right. Next preparation method. Take screenshot. Right. Next preparation method. Sixth, Roman number 6. From Grignard reagent or MgX. From Grignard reagent. Preparation of phenol from Grignard reagent. What is the dissociation of Grignard reagent? How Grignard reagent dissociates? Grignard reagent dissociates into Grignard reagent dissociates R negative and MgX plus. Right. I am taking phenyl magnesium bromide. See. Phenyl magnesium bromide, Grignard reagent. When Grignard reagent is exposed to air or treated with oxygen, one oxygen will be inserted in between magnesium and carbon. One oxygen is inserted between magnesium atom and carbon atom. Here carbon is there in the ring. Right here carbon is there, here magnesium is there. In between these two, oxygen is inserted. O, Mg, Br. Clear? This step is okay. Just insert oxygen in between carbon and magnesium. Right. Next. Hydrolysis of this compound. Right. Add water. Right. After formation of this compound, we do hydrolysis. Look at this. Addition of water. Break this bond. Hydrogen is having positive charge, so it should be added to oxygen. Oxygen is having negative, so hydrogen with the positive adds to oxygen with the negative. And here OH. Okay, right. This is phenol preparation method from Grignard reagent. Once again, see, oxygen is inserted between magnesium and carbon. So oxygen is inserted. Add water to this compound. Break this bond. H here and OH here. So phenol is produced and MgOHBr. You no need to learn the byproduct. Skip the byproduct. Okay. Got it? All of you. Shall we go to next preparation method? Right. Next. Seventh preparation method, preparation number 7. From benzene, preparation from benzene. See, benzene chapter is first year chapter, right? So, we can prepare phenol from benzene directly. We can take benzene and we add some reagents and we get phenol. And indirect step is we have to prepare the benzene first. After that we have to prepare phenol. Clear? Step by step mechanism. Clear? Direct benzene to phenol, no problem. But preparing phenol is another extra reaction. Clear? So we will go with that extra reaction only because conversions may come compared to simple reactions. Step by step reactions will come, right? First of all, I'll give the preparation method of benzene. This is first year topic actually. This is the revision of first year also, right? When calcium right. See, yes, tell me. Slowly you want. Today actually I started late. Right? Okay. Right. CaC2. Calcium carbide. You know how to prepare acetylene. Acetylene for first year. First year alkynes. Acetylene. Yes, good. Acetylene, when subjected to hydrolysis, we get calcium carbide when subjected to hydrolysis. Calcium carbide when added with water produce acetylene. Acetylene when subjected to polymerization in the presence of a red hot iron tube. Red hot iron tube or copper tube. That polymerization takes place to produce benzene. We can prepare phenol directly from benzene, but sometimes you will get conversions like this, right? Calcium carbide when subjected to hydrolysis, acetylene is produced. Acetylene undergo polymerization in the presence of red hot iron tube or copper tube to produce benzene. Right? Okay. This is benzene preparation method. Another preparation method also there for benzene. So many preparation methods we have, but let us take this only, right? Because if we do all the preparation methods, then that related to benzene chapter, not for phenol chapter. So that's why let us take only one, right? Take that benzene. See, benzene when added with oleum also represented like this, H2S2O7, pyrosulfuric acid, H2S2O7, or H2S2O7 also represented like this, H2SO4 plus SO3. H2SO4 plus SO3. See, two hydrogens. Sulfur, two sulfurs. So two sulfurs. 4 oxygens, 3 oxygens. So when you add SO3 to sulfuric acid, you get a oleum, pyrosulfuric acid. So when benzene treated with oleum followed by NaOH followed by acid treatment. So benzene, remember the reagents: benzene, oleum, NaOH, H plus. This combination will produce phenol from benzene. Okay. Benzene to phenol. How to get phenol from benzene? By adding oleum followed by sodium hydroxide treatment followed by acid treatment. Clear all of you? Let us see the mechanism for this. This is optional only. If you are able to remember, then you read, otherwise you remember directly. But I will give the mechanism, step by step mechanism for this method. Okay, from benzene. See, this is your wish completely, right? If you are able to remember, then learn, otherwise remember this direct reaction. When benzene is treated with oleum, we will get benzene sulfonic acid. Its name is benzene sulfonic acid. Benzene sulfonic acid. Benzene sulfonic acid when treated with NaOH, sodium hydroxide, followed by heating. Sodium salt of benzene sulfonate, SO3Na. We will get sodium salt of benzene sulfonate. Sodium salt of benzene sulfonate. Sodium salt of benzene sulfonate. This on treatment with again NaOH. Sodium phenoxide is formed. Sodium phenoxide. This sodium phenoxide on treatment with HCl. H plus are sometimes represented like this, HCl or simply H plus. Produce phenol. This is the mechanism for this step. Right? This is direct reaction and this is the mechanism. Note down. Okay. No. Completed? Completed. Shall we go to next slide? How many preparations are what? Total how many preparations are given to you? 7 preparation methods for phenol. Correct only, na? Last one is 7th one only. 7 preparation methods. Next we will do properties of phenol. Properties of phenol. Properties of phenol. Phenol properties. Once look at this, all of you. Electrophilic substitution reactions. Electrophilic substitution. Benzene itself acts as a nucleophile. Benzene itself acts as a nucleophile. Nucleophile. Electron rich center. Electron rich center. Electrophile is electron deficient. Electrophile is electron deficient. So electrophile attacks on the benzene ring because benzene is electron rich center. Electron denser area. Electron denser area. So electrophile will attack on the benzene ring. Remember, benzene is considered as an electron rich center. Benzene is considered as an electron rich species. Always remember. Right. Once look at this. Take here, sorry, take phenol here, right? OH here. Here I am adding electrophile. See, electrophile is attacking this ring. Here also electrophile is attacking this ring, right? Which is more reactive towards electrophile? This one or this one? Benzene or phenol, which is more reactive towards electrophile, means in which case electrophile attacks readily, fastly. Can you guess? And where rate of the reaction is more? R1 and R2. Sorry. Can you guess? R1 and R2. Why R2 is greater? See, electrophile is coming for the electrons, right? Electrophile requires electrons. For that, electrophile is reaching the ring, attacking the ring. If ring is having more electrons, then electrophile attacks easily, fastly or readily. Phenol is a plus M group. Sorry, OH is a plus M group. OH is a plus M group, electron donating group. This OH group supply electrons to the ring. Then electron density on the ring increases. So electrophile attacks easily. Clear? So R2 is greater than R1. Rate of second reaction is more than rate of first reaction. Okay, clear? So OH group on the benzene ring acts as a ring activating group. Activating means it is increasing the rate of reaction. Ring activating group. Remember this point. So very important reactivity comparison. Phenol and benzene, which is more reactive towards electrophilic substitution phenol, because OH group is electron donating group, supply electrons to the ring, increases electron density, makes attack of electrophile easy. Clear? So reactivity comparison is very important. Phenol is more reactive than benzene towards electrophilic substitution reaction, because OH group is a plus M group, electron donating group, activating group. Clear? After completing another concept, I will give you one sentence. You have to remember that sentence. Is it clear for everybody? Is it clear? This concept is okay for everyone? Any doubt? Right, next. I am taking one plus M group on the benzene ring, and I am taking one minus M group on the benzene ring, and adding electrophile. Here also I am adding electrophile. Let us give the positions: ortho position, meta position, and para position. Ortho position, meta position, and para position. Okay. When plus M group is present, electrophile preferentially attacks ortho position and para position. Okay. Plus M, electrophile in ortho position, plus M, electrophile in para position. Which is major product? Guess. Ortho or para? Which is major? In general, para will be the major one. Why para is major one? Due to less repulsions. See, in ortho, due to more repulsions, it is unstable, minor. So in some cases, it only the major. I will explain that also. But in general, para is the major, because there are no repulsions, right? No hindrance. Clear? This is present that side, this is this side, so stable. So para will be the major product compared to ortho. No doubt in this. This is also first year only. Okay. When minus M group is present, what is the major product? Look at this preferentially go to meta. So based on these two concepts, previous concept and this concept, we can give one generalized statement, right? OH group on the benzene ring is ring activating group and orthopara directing group. Very, very important statement. OH group on the benzene ring is ring activating group and orthopara directing group. Okay, write that statement. Shall I clear this? Write one important note. OH group on benzene ring is ring activating group and orthopara directing group. Ring activating group and orthopara directing group. So when we take phenol, electrophile attacks ortho and para position, right? So phenol characteristic property is electrophilic substitution reaction. Phenol generally no need of any catalyst or no need of any electrophile generator because OH is a strong donating group, so no need of any particular electrophile generator. Okay, no need of any catalyst. Is a donating group. See the symbol. Electrons enter into the ring. This statement is important. Sometimes they will give wrong statements. OH group on the benzene ring is the ring activating. Instead of this word, they will give the ring deactivating. Wrong statement. Orthopara directing, they will give meta directing. They will do some different statements. Okay, right. Shall we start the properties? Okay, all of you. Right. First property. Acidic nature is completed now, everybody. I explained acidic nature of phenol at the beginning of the chapter. Acidic nature plus M minus M. Acidic nature question will come, no doubt. Right, I already prepared worksheets, we will do the questions also. Right. First chemical property of phenol. First chemical property, reaction with bromine water and bromine in CS2, carbon disulfide CS2 or chloroform CHCl3. Polar solvent. Reaction of phenol with bromine in polar solvent. Reaction of phenol with bromine in a non-polar solvent. CS2, carbon disulfide, non-polar solvent. What are the products? Bromine or bromine water. Bromine water CHCl3. Bromine water CHCl3. This is major actually. Para is the major product. Can you give its name? 1, 2, 3, 4, 5, 6. What is it? C? 2, 4, 6 tribromo-phenol. Tribromo-phenol. Polybromination takes place. Polybromination is taking place. Right, when bromine is added in the presence of water, polybromination. With CS2, carbon disulfide or chloroform, CS2, bromine CS2, you can take like this also, bromine monobromination takes place, non-polar solvent.